Good afternoon, ladies and gentlemen. My name is Henrietta Moore. I am the Director of the Institute for Global Prosperity. It's my great pleasure this afternoon to welcome my colleague from Sustainable Resources, Professor Raimund Bleischwitz, who is Chair in Sustainable Resources. He came to UCL from the UCL Institute. He is an economist by training. So he has now converted, I think, and works on environmental and resource economics, eco-innovation.
Here the discussion begins.
Yes. And raw material conflicts. And we welcome him here this afternoon to the seminar for the IGP because Raimund is an expert on sustainable resource management. So I conclude.
Thank you, Henrietta, for those kind words, which gives me the kind of beginning of a discussion. You can probably remember who wrote one of the first books about prosperity, which was entitled The Wealth of Nations. And that was an economist at that time. This book is quite under discussion, but it was also a guy who did the ethics. So he was a moral philosopher at that time and an economist, and in a way I tend to believe this is a pretty good combination of applying rigid academic thinking with some normative ideas, at the same time indeed have the idea to work on the prosperity or the wealth of nations. And the title today, Resources in a Finite World, is indeed related to what we do at the Institute for Sustainable Resources, to look at the resource-related risks and opportunities for development pathways here in the UK, in the European Union, but in particular also worldwide. And I may just start to engage you looking at those two simple pictures here, where you could imagine that resources are important, and you can tell quite different narratives with resources. And one resource-related narrative is related to constraints. And some of you may remember the discussion we've had about limits to growth. And indeed, there is an ongoing discussion about resource wars. And you can imagine that if we accept the notion that resources are limited and there's a growing population, you end up with some nasty ideas of how the future might look like. And we should certainly have a discussion about this perspective. On the other hand, you could also look at history and change in terms of how change has happened in the past, how mankind has always been able, up to now, to overcome any scarcity, any restriction with help of change, behavioral change, institutional change, technological change. And you'll also be familiar with some concepts such as resource efficiency. So we might test this concept and then explore together to what extent this might be able to lead us into a more prosperous future for more people on this planet. And this is kind of the structure of my talk today, where we probably are well advised to start where we are right now. And it's no big surprise to look around and realize that many of the existing interstate tensions and existing conflicts have a root cause, have a strong causality at least, which is related to resources. And of course the Ukraine-Russia conflict springs into mind, but you can also look around and see what happens these days, since say 2 years or so, between China and its neighbors in the China Seas, where there is a conflict about fishery rights and access to minerals and fossil fuels in the Chinese Sea, which has led to conflicts with the neighboring countries of Japan, of Vietnam, and with others. And it has a number of interesting features, not the least of it being that 2 more nationalist governments have been elected by the voters in the last year. And you can imagine that these people, and this includes the Japanese government, are not exactly on the kind of, we will deliberate, we will do the diplomacy kind of international relation part. And the same happens with regard to a number of rivers. We will also think that looking at the European history, looking at the North American history, there's a great tradition of sharing the use of rivers, the Colorado, the Rhine, and many others, between borders, between neighbors. So the lessons learned can be applied. But in Asia and along the Nile River, it's actually much harder. There is a pressing need from population, from development planners, from energy engineers to build up hydro dams, to look at how you can also put some pressure on your downstream neighbors in having then the power to regulate the supply of water delivered to your downstream neighbors. And this happens not just in Asia, also along the Nile, and in a number of other countries. And I look at the people here, when we look at the drought in Brazil, for instance, this is not an interstate issue, but it also has started to happen, and it could mean that the hydro-based electricity system in Brazil is under stress and might put some of the development questions might put some of the development perspectives in question. So resource-related conflicts happen on the ground, but they can also happen between states and at an international scale. And there are certainly reasons to look at each of these individual cases with great detail and respect and try to come up with potential solutions on how sharing agreements can be reached. But indeed, it is all also related to the challenges of climate change. There is a strong commitment by the majority of the nations to limit the temperature increase to 2 degrees Celsius, with the implication that the emissions of carbon dioxide must be reduced by some 80% or so in the next decades. Just to mention that. But it's not the only environmental challenge. And I usually tend to warn people that carbon dioxide, greenhouse gases, is incredibly complex. But environmental change goes beyond. We certainly also have to look at what is called the planetary boundaries, where more boundaries have been defined by Earth scientists that are likely to be transgressed. And climate change is one of them. Biodiversity loss, or now more recently in an updated paper, it's called the biosphere integrity, which is under stress, which means local ecosystems basically, and also the influx of a number of nutrients into ecosystem also causes a number of negative effects, the nitrogen cycle, the global nitrogen cycle. So that's something where the environmental research comes up with findings suggesting the challenges are even larger in a way. It also is interesting with regard to land use when we try to identify a resource which is ultimately scarce, that's land or arable land. There's hardly a way of expanding the amount of arable land that exists on the Earth's surface. We can think about all kinds of futuristic ideas, but that is one of the resources which is ultimately limited. And one of the other concepts which I find intriguing is the resource nexus. The fact that resources are interrelated and we can usually not produce any useful resource without using another resource. I've mentioned the electricity case, so energy and the water use that is needed for energy production is a clear case in point. We can also look at biofuel production, where the case has been made in the last 5 to 10 years that the dramatic increase in demanding more biofuels has created additional demand for land, for water, and has put many local communities in conflict with food production. So these resource nexus ideas are interesting, both as a concept, but also as a way of looking at resources in a more holistic manner, rather than looking at single silos of different, what may be called critical or whatever materials. So the nexus is interesting. To illustrate this, and it comes with the environmental but also social challenges of food security. When we look at one of the important fertilizers, the chemical element of nitrogen, the nitrogen that's being used in a country such as China is produced out of coal. So a side product of coal is ammonium. And ammonium is then used as a byproduct and as a feedstock for nitrogen production. And the fact that China now has reduced the domestic coal production has a side effect in that they not only need to import more coal from Australia, which is less sulfur concentrated, so better from an environmental perspective, but they also need to look for access to other sources of nitrogen fertilizer. And take it together with the trend, which shows clearly that the application of fertilizer has happened in China in quite an inefficient manner. We did the statistics with a couple of people that the grain production in China is much flatter than the use of nitrogen fertilizers, which indicates an increasing gap or a clear trend that in the future the demand for nitrogen fertilizers will be even bigger. And if China then changes the diet even, you could think that China will become a major demand force on the world market for fertilizers, but also for food production, just to mention that. So the resource nexus here of how you produce fertilizers, how you organize a supply chain, a whole value chain, how you try to recapture fertilizers from what? Any idea?
Human waste.
Human waste, yeah, you put it very nicely. So it's human-based, but it's also wastewater, because human waste in the industrialized country usually goes into wastewater. So you would need to align the agricultural system with the human demand and production and the wastewater system, and then you could come up with ideas of how you could establish markets for secondary fertilizers or secondary nitrogen. And that's not easy. So just to illustrate this. So the resource nexus is interesting. I should possibly also just show you that I was co-authoring a book on the resource nexus, which probably explains why I'm just doing the whole lecture about the resource nexus thing. But it's really interesting here. And there are many ideas of what exactly are the resources that should be captured by this nexus. There is a clear stream of research that looks into the water, energy, food nexus for a number of reasons. And the claim I would like to make is that it should also have an angle on minerals. Why that? If we look at the overall amount of resources used, minerals make up for some 50% of resource use. You have main categories. And in the methodology of material flow analysis, which I will explain in a minute, we have the categories of fossil fuels, of minerals, of metals and abiotic resources. And minerals and metals together make up for some 50%. So ignoring this vast stream of resources used throughout society shouldn't be done if you look at resources in a more holistic manner. There is indeed also the clear case that all the urbanization processes going on, they need a lot of construction materials. So you have a better eye on looking at urbanization processes if you also capture minerals. And you could eventually also argue that the special cases of metals, of critical materials and fertilizers need to be taken into account for a number of reasons, and the entry to a more comprehensive monitoring system would be monitoring minerals. So that's a clear pledge for looking at the resource nexus that relates to those 5 categories here, so water, energy and food, but also land and minerals. And probably not need to allude on this China Dam case study here again. So what is interesting from the perspective of what constitutes a sustainable resource is not the traditional notion of depletion, static availability, reserves under the ground, which is like the classical resource economic or geologic perspective, but more the holistic way of how resources are used throughout societies, the environmental pressure that can be related to the use of resources. And this sort of graphic illustrates the approach that we need to start looking at resources in a life cycle-wide perspective. Who demands resources for what purpose? You see all the Apple and other devices being around, which are composed out of a number of materials. And then when you do the metrics, you also realize that the most material intensive production phase is, or stage of the supply chain is right in the beginning, So extraction and early production processes are relevant for the reasons of water intensity, energy intensity, material intensity. You could also apply life cycle analysis, a more sophisticated tool to look at products and materials, and you usually also then discover that this is the most environmentally intensive phase for using resources. So this again leads to a more holistic understanding of how resources can be used in a more sustainable manner. So what does it mean for the idea of the normative assumption that we should use resources in a more sustainable manner? Should we abandon the idea that our resources are scarce? That's, on the one hand, too easy. On the other hand, we should take a more critical look. We believe the geologic surveys of the world consistently arguing that most resources are actually abundantly available. If we wait for the peak whatsoever point, we will be in a miserable situation. All the peak oil discussions of the past, all the peak everything discussions of the past usually have faded away after new discoveries. So that's a misleading entry point into the sustainability discussion. There is enough evidence to ensure that base metals, base materials, and even base fossil fuels are available for at least the next 200 years. And the environmental pressure requires a transition which should begin now. So that's not the point from which we could derive targets or maximum thresholds on the overall use of natural resources. Nevertheless, is there a need for a reduction? Yes, it is. There is a need for reducing the overall amount of resources used in society stemming from the environmental constraints, basically. And these environmental constraints come from two sources, basically. One is the limited absorptive capacity of ecosystems, which is widely acknowledged in the meantime, but also the limited capacity to deal with the inputs. So we need to keep this input-oriented perspective in order to realize that in a time where actually declining ore grades and extraction going on in more remote places require more energy, both for the extraction and for the transportation, and more water, that the use of those scarce resources should also be monitored and puts additional or brings along additional arguments to reduce the amount of resources used in society. Would it be possible then to derive a target similar to 2 degrees Celsius? That's hard. And I myself, but even more a couple of colleagues, have tried to do that since 10, 20 years. You see some numbers around like 6 tons per capita. This should be one of the targets. There are sophisticated indicator schemes in place proposed by people where the resources are measured, and still deriving targets out of indicators is methodologically quite challenging. You need to have additional criteria. If you look at the planetary boundary scope, you can not immediately derive resource use targets out of the planetary boundaries. And believe me, we have tried and we keep on trying. So all you can say at this point in time that it is really rational to start changing direction, changing course from using ever more resources to limiting, reducing the amount of resources used in society. At the same time, we also have a need to, despite our resource nexus holistic thinking, to look at different categories. The case for the reduction of fossil fuels is probably strongest because of the direct link to CO2 emissions and a number of other air pollutants. The case for a reduction of construction minerals is quite less convincing because construction minerals put pressure on local environmental systems, but it's less convincing. we also see that with some low-carbon, environmentally friendly scenarios, we need some resources in a greater amount in the future. One is fertilizer. Most critical materials will also be needed in an increasing number. There are other materials such as copper, where with all energy efficiency, renewable energy scenarios I'm aware of, you will need more copper in the future. So thinking about reduction will probably have to come along with a more asymmetrical structure, where you need to reduce some resources stronger and some others not, because you need them in the future, and then still have like an overarching direction of using less resources over time and across countries. So that's a kind of the picture of how I look at it. Now, the interesting question begins when the Europeans, and eventually joined by Japan or some other like-minded countries, start discussing a reduction in the use of resources. How does it fit to development perspectives, in particular to perspectives of resource-rich countries? Would you really believe that you get alliances with African countries, with Latin American countries, with the 100 or so resource-rich countries in the world, with a message that comes like, we have to reduce now, we have to go down by 80%, and whatever you intend to do, stop. That's the end of the discussion. There are legitimate reasons from a global prosperity, but also from a local prosperity perspective, to realize that the demand for housing, for mobility, for food, to mention just these basic needs, will have to come along with increasing resources used in a number of poor areas. And when you look at what actually happens in Africa, I put the Africa mining vision here on the screen, these countries have quite ambitious plans to turn natural endowments into prosperity in whatever sense it is used in these documents. So we clearly have a conflict about a different future if we looked at resources only from the imperative of reducing the demand for resources worldwide. What can we do? So at this point, even with eventually the European Union willing to go ahead, willing to establish green markets, green lead markets, we still have high risk of what can be called a perfect storm, which would include environmental change still going on, having an impact on fragile countries, on a resource situation. And let us just speculate here about how this could affect commodity markets. I would point at one scenario where important suppliers struggle to cope with the water and food crisis, which causes social unrest and then breaks down some essential supply chain. Think about Nigeria, for instance, with huge exports of oil. Think about a number of other countries where you could imagine this is not unlikely to happen in the future. And it's particularly interesting also for a number of more critical material producers, where we could also think that all the ideas about having access to critical materials is a bit more critical from this environmental political perspective. We might also think about regions where the tensions are already relatively high. Think about Pakistan, for instance, regions with nuclear weapons. When they are hit by food crisis, water crisis type of scenarios, you could think that all different kinds of inconvenient events could happen, or the world shipping system is not unlikely to come under stress. We have seen many piracy incidents 2-3 years ago at the Horn of Africa, the West African coastline, and this has declined for a number of reasons, but there is now more piracy going on at the Strait of Malacca. So we could imagine that poor people being forced to become pirates in a way will find it quite attractive to look at the huge ships, and then we may have emerging between piracy and terrorism and organized crime, and putting it all together might also bring the UK, might bring the Europeans under more political and economic stress than I might think today. And indeed, last but not least, geopolitical powers. Do we have any guarantee that the superpowers would not use weapons in the future? I think, well, these days we have started to think quite critically about the peace order we could establish some years ago, and we realize how fragile the whole situation is. So it is, even with a like-minded UK and Europe, not the kind of future pathway to prosperity that we would like to see. What is the strategic implication? First, climate change is important, but it should be embedded in broader strategies of sustainable resource management. I would also emphasize that shifting the use of non-renewable resources onto renewable resources is not an option, because the ecosystem just can't produce the amount of resources needed from today's perspective. So a key to understanding and a key to sustainable resources is to manage non-renewable resources in a more sustainable manner. And of course, here again the notion comes in, resource efficiency, using resources in a more efficient manner. This is one of the key concepts that could bring more or less stress on the ecosystems, but it needs to be done in a slightly different manner, and I will explain how in a minute. It needs to come at least with a life cycle perspective and should encompass minerals, but also energy, water, land, and biotic resources. So a more holistic understanding of what resource efficiency means. This could be the green economy of the future. And if you compare it with today's resource use, it means that the amount of resources used in the future should be significantly lower, depending on, say, different type of economies. And you realize that the expectation is that a significant share of the resources used in the future would be biotic resources. But you also realize, for the reasons I just have mentioned, that most likely we need to expect that a number of the resources used in the future would be non-renewable resources, which would be metals, minerals, and eventually even fossil fuels. We not necessarily have to go down to zero. We might use like a base load of 10-20% of fossil fuels if it happens that we can capture the carbon and eventually also put it into reuse systems so that chemistry might be able to create a new type of polymers out of reused carbon. So that might be quite interesting. The point is indeed that we have to establish more globally oriented systems to drive the direction first towards reducing less for the industrialized countries, and also reshuffle the mixture by means of incentives and institutions so that no resource and no ecosystem is going to be endangered. You could also then start designing different sub-societies or critical elements in societies based on this overarching vision. I would think that indeed industry should be more resource efficient and recycling based, kind of a circular economy idea. But just to make the point here, from circular economy perspective, you would still think you can use as many resources as you want because it's circular. From the perspective I just outlined, you need to reduce the amount of resources. Then the urbanization could be realized more by steady stock type of thinking, so that at least in the European and the more mature economies, you would not need to have an expansion of urban spaces. Infrastructure to become solarized. And indeed, bioeconomy or balanced bioeconomy would be part of the game. But I would stress again that it's not the whole story because of the reasons I've mentioned. So, okay, the more positive part begins. When you look around, there are so many well-documented, verified cases of how resources could be used in a more efficient manner. And it's so interesting to look into some of these small and medium-sized companies which have done it at their point in the production in the society with different type of furniture, consumption of rinsing water being reduced within a component manufacturing company, paint spray gun which is produced by a small manufacturer which uses less less paint to be put on the wall. It reduces basically the waste. You know, the scale logistic thing which actually works with a diesel engine in combination with Sky Sales, which reduces the amount of diesel, I would say, by 30%. The interesting thing is that since commodities have a price, and since most resources used in societies have a price, there is a strong incentive for companies, for consumers also, to realize savings that are available here. And that's a business case. At least it was a business case in the 10 and more years when the commodity prices were high. And it's significant. It increases the profitability within companies. It contributes significantly to cost saving, more in many cases than savings on labor, because the share of material cost in many manufacturing companies is higher than the share of labor cost. And it could then also lead to a more competitive industry in some cases. So that's interesting. And you could go on and on how this is done. I guess it is important here with innovation economics to make a distinction between process and product innovation. Process innovation is where each individual company has an immediate return. The cost savings are realized where the investment is being done. It's a matter then of the payback period. It might be longer than expected, but there is good evidence that there are payback periods of 6 months, 1 year, quite in the range of what an investor usually expects. It's much harder to realize product innovation because you usually don't know what the consumer expects. So there's more uncertainty about demand. But realizing the full range of process innovation is a beginning. You may call it low-hanging fruits, you may call it win-win. It's usually harder to really do it. There are many barriers to do it. But one of the attempts, therefore, is indeed to spread the word, to spread good practices, to organize agencies, programs, mechanisms by which these process innovation can be done. It usually stops there, and that's the unfortunate thing. And it's not what resource efficiency is really about. When you just do the process innovation, the impact is fairly limited. It's much more interesting to look at the global scale, what can be done with regard to key industries, key areas, where currently the resource intensity is very high. This is a calculation done by McKinsey 2-3 years ago. They didn't look into the full spectrum, but they checked energy, water, and land and steel. So they took steel as a sort of proxy for other materials. And you realize that actually the interesting story is that it's not that everybody needs to do everything at the same time. You can focus both from a business perspective, but also from the perspective of, say, political planning, organizing societies. And you realize some of these areas are the usual suspicious. Buildings are critically important. But you also have the food waste problematic, the whole agricultural story, where you can realize a better resource efficient performance at the same time, yielding better results for users of food, for consumers, etc. So what does it mean? We thought for a certain time that the prices will do it. Now we realize the oil price is down to $50 per barrel for a number of reasons. It was at, say, 150. So the price mechanism certainly is not the key source. The expectation is fundamentally uncertain whether prices will go up again in the near-term future, in the long-term future, maybe not even in the long-term future for a number of reasons. So that's what makes it much harder to believe in the price mechanism. What's also empirically tested is that the price mechanism itself, as long as the prices are volatile, has struggled to communicate the message. if people expect the prices to be volatile even in a smaller range of high resource prices, it's usually difficult for a purchasing manager in a company to convince the top level managers that investments need to be done which may have a return of 5 years rather than 5 months. So coping with price mechanism is one of the key, and understanding also better, and here I go beyond the area of economics, you are right, to understand better how you incorporate scarcity signals which partly come through the price mechanism into economic or societal decision making. And the price mechanism plays a role, but the signals need to be strengthened. So what could we expect? What could be the macroeconomic outcome? Would we need to compromise on growth, on well-being, on whatsoever? The modeling exercises I was involved in come out with a positive story, which I can explain. So the macro indicators would be increased economic growth against business as usual, a rise in employment, maybe not spectacular, but significant, a reduction of public debts, and environmental benefits calculated here as drastically reduced CO2 emissions. At the same time also an absolute reduction in the use of natural resources measured on a life cycle-wide basis, which comes through the indicator of the total material requirement, so that also the imports and the what's called ecological rucksacks caused by mining processes is being reduced. You may say, that's magic, I can't believe it. So what is the mechanism? And for a country such as Germany, for which this calculation has been done, is basically not that difficult, because you substitute capital-intensive processes happening outside the country through labor-intensive processes and intelligent-intensive processes within your country. Like using less oil, importing less oil, and doing home insulation. This creates jobs. It is dependent on skills, on technologies, so it creates a whole industry of smart producers, and it leads to increasing employment. And the impact of increasing employment then is that you need less public expenditures for social health, unemployment insurance, etc., which then helps to trigger the standard growth mechanism. And at the same time, if you do these things, then you have also the environmental benefits. Still, there are some critical assumptions in it. One of the stories here is that you don't stop with the process innovation. You have a sort of model-based optimistic assumption that whatever productivity increase you realize, it's reinvested in manufacturing. It's not translated into higher wages, higher bonuses for the management, etc. And you may imagine that this is a modeling world which is good for economists and other like-minded people, may call it like that, but in reality it will turn out to be difficult. And also all the information-based constraints are usually a bit defined out of the scope, but the model we used here, is based on empirical observations. So it has a built-in mechanisms of some information asymmetries, but still we could go into the details if you're interested. There's still some optimism around. Nevertheless, it is an interesting story. And many people, in particular in the political debate, have difficulties to understand it. The whole debate about degrowth that's been starting also usually does not buy in here, but this is indeed where the academic debate is interesting, and research can contribute to make it a bit more transparent on what type of model and what the critical assumptions are could yield those results. All right. A critical remark on my friends from environmental economics here. So what does it mean when we look at what's usually done in environmental economics? You have the notion that the natural capital should be kept intact, maintenance of natural capital stock, one of the key ingredients of sustainability, fair enough. When we look at, however, how resources are treated in the national capital accounting framework, it is not really accurate. In the definition, you usually see minerals as being accounted for as part of natural capital. At the same time, when you then follow what the researchers do, they are more interested in ecosystem dynamics. The graph they developed here also is not specific about where the minerals are in, how minerals are translated into goods and products. So the critical question would be, does it accurately reflect minerals and other resources? Does it lead to also an understanding, or does it enhance understanding of how they are used throughout value chains and in societies? Or does it even contribute to the knowledge about why and how resources ought to be used in a more sustainable manner? And I'm a bit afraid, just to provoke some people here, that the answer is 3 times no. So there are some inherent limitations to this natural capital accounting framework. And indeed, when you look at typical value chain representations, which could explain the use of resources throughout societies, which could also explain the pressures that comes from using the resources on the different ecosystem, you see a need to complement the natural capital accounting framework through other tools. And one of those tools could be material flow analysis, where you have an established accounting framework, which is supported by an OECD handbook through Eurostat statistics, etc., and explains how societies use resources, and could also explain, I would say, better the international value chains and what happens within the society itself, with a notion here which is called net addition to stocks, which accounts for urbanization processes, and then different ways also to look at material throughput, which is like a white box here. But when you go into, say, input-output tables, you can also establish metrics of which industries, which areas of consumption use what type of resources. So that's a sort of a necessary complement. We could also do it a bit more sophisticated because we are here at the Bartlett faculty for the built environment, but I guess we just have to move on. So resource efficiency, I call it 2.0. Reloaded is certainly much broader than what we have seen in the last 10 years or so. The Nexus dimension is lacking yet. What is also a dimension that needs in prevailing resource efficiency stories is eco-innovation in extractive industry. It just doesn't happen so far, at least not to the extent we would like to see it happen. The international scope usually comes too short. A business policy interface is hardly analyzed. You usually have somewhat naive assumption that business runs it alone. And it could also mean that we start formulating, I call it soft extraction pathways for resource-rich developing countries. Adopting this strategy is also likely to support the Paris Conference on Climate Change, because it could help to build alliances with industry and with more developing countries. And indeed, you also find sources for knowledge. You find a number of abbreviations here, but I could explain more about it in the discussion. So what would it mean, international resource politics? I think there is a need for an elaborated international resource politics, which could start relatively easily with better information, transparency, accountability. I'll come to it in a minute. Better data being available. A resource agency which could play a similar role, such as International Energy Agency. You could also formulate some areas where action can be done, like on metals recycling, on phosphorus, on other fertilizers. You could also build up a more comprehensive approach based on what exists with the raw material agreements between a number of countries, which could be revised to integrate more environmental concerns. And indeed, there is a much longer agenda on a more sustainable world economy. I would like to briefly walk with you. So one of the proposals would be to establish an international metal recycling covenant, a contract where you would need to engage with countries, but also could engage with industries, which would be recycling industries, but also manufacturing industries, which is interested in having more sources of supply, such as automotive or electronic industry. And what it could do, step by step, is to go to some of the target countries, which could be Kazakhstan or Nigeria, where due to shipping and transportation statistics, there's a lot of secondary goods moving into these countries, and then work to establish better recycling facilities there. And this could create a sort of double or triple loop recycling system, where you would recycle the base metals on the ground in those countries, but could also extract the more critical materials where you need more sophisticated facilities to treat them, and then ship them back to those locations where the critical materials could be recycled. So this would be a more multi-layered type of circular economy, focusing on metals, where you need a limited number of countries to engage in, a limited number of industries, and indeed quite a number of stakeholders to do it. Also, I started to talk about mining. Mining is indeed a quite interesting industry. It's quite a strong industry in terms of value added and the contribution they do in a number of countries. And by far, the innovation contribution is not really significant. They basically, well, have made some progress, but when you look at the share of R&D investments compared to, say, pharmaceutical or ICT industry, the share here in mining industry is significantly lower. So it's time to catch up. And it's also interesting to realize the potential where you could do mining in a much better way, like applying renewable energies in areas where the sun is shining, like Australia. Also reduce the amount of mining waste, make more use of the critical resources that are part of mining waste so far, and indeed also establish a more sustainable water use. And imagine a situation where you would do like copper mining in Southern America, where the electricity would be produced by green energies, and the water wouldn't be taken away from scarce river management system, but taken out of desalination processes, and the electricity for which would also be produced by renewable energies. You would have a quite different beginning of the extraction mechanism from a, say, environmental technology point of view. And indeed, you could also imagine that this goes along the whole value chain, where the industry itself builds up a reputation for managing ecosystems, for also organizing a knowledge system where exactly the resources are being used, and what would be the points in the value chain where you could do a more circular economy type of recycling and a better design indeed of products, where the least possible use of those resources is then organized, which goes on to urban mining processes in the future, where you could imagine that the Europeans build up knowledge on how in mature urban areas you could do recycling of the stocks, and this knowledge is then disseminated to growing cities in Africa and Asia, where then in 20 or 30 years from now, with proper information system and property rights system in place, you could also recycle much more of these urban spaces than you are likely to do it in the current pathway. So engaging mining in sustainable resource management, in my perspective, is a good way forward. It's not yet really happening, so it's an opportunity, but under the constraints I've started to discuss, I think it's one of the interesting ways. Transparency is high on the agenda, as I've just mentioned. You may be interested, or you may know that initiatives exist, manifold, Extractive Industries Transparency Initiative. The main quest for transparency comes from the development community, arguing that in the past, in the present, intransparency, in particular in extractive industries, has been a main source for corruption in many countries. Now, for a number of reasons. So bringing transparency in the financial flows between extractive industries and regulatory authorities in countries is a key, and actually with EITI and with Dodd-Frank and the European regulation, there is much progress that has happened in the last 2 to 5 years. But I would argue it's time to ask for more. Why only proposing financial transparency? Why not also requesting disclosure on environmental information, on the energy used in extractive processes, on the water used in extractive processes, on the mining waste amount, and bring this together in these transparency reports that are being discussed, that are being made publicly available. The next step that is going on is to establish national stakeholder forums in all the countries where EITI is engaged, in brackets, not in China, not in Russia, but in many of the other developing countries, and then use the round tables of stakeholders in those countries as round tables for resource management, for developing pathways on how the resource extraction should be organized in those countries. So make it a more civil society-driven process on how resource-rich countries should organize the future. And the transparency process is probably quite a powerful tool these days. And with support of European Union, US, extractive industries, and the countries in question, we could expect more happening in that area. So what would it mean for resource policies in resource-rich countries to complement resource efficiency strategies? It would be certainly an approach based on participatory planning, based on integrated assessment, integrated environmental assessment, which value ecosystem services, include also food security issues, negative externalities, which is built along transparency and accountability notions to include also state-owned enterprises for sure. And then we could think of economic incentives playing a role. Why should royalties only come from exports? Why not having extraction taxes, where there could be a unit-based extraction scheme which gives more fiscal solidity for the extractive economies, at the same time establishes a mechanism on commodity markets that the prices are less volatile, presumably, certainly higher than without taxes, but giving strong incentives throughout the value chain to spur resource efficiency. So it could be a system which benefits resource-rich developing countries and gives a incentive for resource efficiency, which is an interesting mechanism. It could also well come along with what is called citizen dividends, so that not all the revenues goes into the central government budget, but could also go along with local shareholder participation, so that part of the revenues then goes into the citizen dividend, so that the people in particular in the area where the extraction happens have like a direct income and could use it for purposes of what we could call sustainable development. So that's interesting that resources could probably also be used in this type of development processes. So to come to an end, it opens manifold ways into interesting, I would say better, more sustainable futures. It would also allow for alliances to be established, transnational corporations being interested in that type of resource management for reasons of stability, resilience, credibility, reputation, systemic eco-innovation, etc. Citizen indeed too, driven by, say, European consumers who have started to establish green consumerism here, but also then coming along with local people on the ground. And indeed, still a strong case for having strong environmental actors, because without green NGOs, you couldn't do all those things for a number of reasons. Which would mean, and we still need to translate it into models, that we could establish those, what I call soft extraction pathways for the next 20 to 30 years, and having a more long-term oriented perspective of reducing the amount of resources used globally than later on, which is a system which is partly in line with most of the low carbon scenarios, where you also have like a peak around, well, 2020 is the most optimistic assumption, more realistically 2025, 2030, which still is optimistic, by the way. but then have like a delayed peak for the use of resources around 2030, 40, 50, etc. Indeed, it calls for what we discussed a minute ago, inclusive institutions at a number of levels. So the research agenda, which I find fascinating, that could be extracted here, would indeed be a stream for what I like to call new resource economics, in line with another branch of economics, which is new institutional economics, evolutionary economics, a quite interesting discussion, but indeed also a number of interdisciplinary collaborations with your institute, but also with other human sciences, with geology, with engineering, etc. But also to understand better the resource nexus and resource efficiency agenda, where I would think the next step would be to establish better data hubs, where you have a better comparability of data, and then establish metrics. What type of industry uses what type of resources? Could we establish benchmarks eventually, and then have a better understanding of what the minimum amount required is compared to business as usual. Modeling and foresight, that's definitely interesting. You may have noticed that I was partly referring to modeling results, but only for 1 or 2 countries available up to now, not pretty much. And at the same time also a need to establish new models that incorporate resources and the resource nexus. Happy to announce that we are working on this. We now have a collaboration, small scale I should say, with OECD to work with their what is called CGE model and make proposals on how the resource nexus could be established within CGE models. At the same time, we are about to hire somebody to do it here. So we would really like to establish a model, and it will presumably be a CGE model, which better accounts for resources here at UCL at the Institute. And indeed, the fascinating thing would be to speak about prosperity pathways, not only for the UK, but in particular also for African countries and a number of other resource-rich countries, and think about how resources could be utilized to do what probably you define better than I could define it in terms of prosperity for the people and different ideas of what prosperity means. I'm happy also to announce that we have submitted to the faculty a proposal to establish a new master on sustainable resources here, which should start in 2016. So the few students here in the room will realize that's pretty much too late for them, but hopefully there are younger people around who might be interested to join us here. And I just wish to thank you, and I look forward to the discussion with you.
Thank you very much.